All right, good morning, everyone. I've got a special one here for you today. I'm here with Darryl Wright of Southern Company. Southern Company is the parent company of several power companies across the country, including here locally, Georgia Power. Here's an excerpt from Southern Company's About Us. We've made our name as a leading producer of clean, safe, reliable, and affordable energy, and we approach each day as a vital step in building the future of energy. Mr. Wright, I've been talking to you quite a bit about what you're working on. Why don't it certainly sounds futuristic to me? Why don't you tell us your position at Southern Company and what you've been working on?
Sure. So first, thanks for having me today. I do lead the AR and VR Center of Excellence at Southern Company. What we focus on are creating augmented reality and virtual reality experiences for different parts of the company. As you mentioned, we at Southern Company we do own several subsidiary companies, including Georgia Power, Alabama Power, and others. Our first strong VR project was an educational experience for Alabama Power, where we created a VR game to take into the high schools so that high schoolers can learn a little better about different sorts of electricity hazards in the home and then how to safely navigate those hazards.
Yeah, why don't you tell us why you've targeted the high school audience?
So it turns out that one of the strongest areas and strongest group of people that actually get electrocuted are 20-year-old males. I guess at that age we all think we're invincible as a guy, but so we want to sort of reach them before they go out and essentially do something stupid. And so we have several different scenarios set up in the home that covers electrical fires, that covers down power lines outside, and even uh, safety on starting generators in the garage.
All right, very cool. Can you tell me a little bit about like the hardware and software that's behind this?
Yes, so we chose to use the Oculus Quest. It's a VR device that is standalone. There's several different scales of VR devices. Among them are ones that you connect to the computer, which obviously uses the power of the computer, and you're tethered generally with a cord. And others are more standalone, like the Quest. The Quest is relatively new. It came out last year, and it adds a lot of power but without having you connect it to a computer. And for us, that's kind of important because if you take a mobile computer into the classroom, you're talking about a lot of expense. You're talking about, a $2,000 laptop that's capable of running VR because you have to have a strong graphics card. And so when you add that to the headset, then you're talking three or maybe $4,000 per station just to set up and run this, and then you're connected to you're connected with a line. There can be issues with tripping on it or just setting up, and the Quest offers the freedom to go in and be able to set up without having a computer. It's only about $500, which is much cheaper, but it's not as powerful. So you have to do a lot of optimizations, and you have to really be careful during the development process. We did, for this experience at least, we use Unity, which is a game engine that's used for multi-platform game development, meaning it can be used on mobile devices like your iPhone or Android. It can be used for VR development, for augmented reality development, and even on console development. And it's also used in other areas like simulation. It's starting to be used for, and even like training for AI.
Yeah, so let's touch a little bit on Unity. It's a game development like engine. It handles the physics, right, behind most of this stuff.
Right. Well, it handles the physics. It also handles just in general a lot of the graphics. Like when you're creating games or virtual worlds, you have to literally create the entire world. So there's there's what are called meshes that you put into there that represent objects in the real world. Like if I wanted to model my office here, I would have to model monitors and headsets and chairs, and all these are brought in. And Unity provides you ways to handle that and provides you ways that you can program to interact with those different objects in the world. So it's a little bit more than just physics because it handles the entire rendering of the 3D space for you, which is a huge um, a huge task. And most of us don't have the teams or really the time to develop our own 3D engines. A lot of AAA games do, but if you don't have that kind of time, or if you're more of an indie developer, you want to really focus on the game versus creating the game engine to actually even create and run the game.
Okay, help out our viewers a little bit because they're used to like text-based coding, like writing in Java. How do you never see text with Unity? Is it effectively drag and drop? How does this work?
So it's a mixture. It is some drag and drop, but the coding side is actually in Unity done in C Sharp, which is um, pretty close to Java. There are differences, and I don't want to get into
Right.
which is better and all that, but Unity does use C Sharp, which is like a sort of offset or simpler version of C, which is, or actually C++, because it is object oriented. It still follows all those principles, but it is does make it easier to code.
Awesome. Can you tell us a little bit what the development process was like for this?
Right. So for this one, uh, we do have, let's see, if you want to put up the slides, we go through a little bit of the development process in that, because there's a lot of production stages that you do for developing this or really any game. Um, and it involves more than just coding, right? Because there's a lot of upfront planning and design that has to go into these things. Uh, so if we actually had a team that actually worked on this, um, where we have like a project manager and creative director that's kind of me on that, as well as a writer for the experience. We have an art director on there. We started with storyboard artists. We have those. Um, you have environment designers, 3D modelers, animators. So we have this large team that we put together. And as we start to go through the development process, there's three major areas of production. Um, and this is just, keep in mind, this is just a very high level overview. There's a pre-production phase, the beginning of the production, and then the actual production itself. So on the pre-production phase, we started out with comparable experiences. And on that, you go out and you sort of look at the landscape of what other games or applications exist that are somewhat similar to yours. And it doesn't have to be exactly like yours, but you want to take conventions and things that are out there already and apply them to your game so you're not confusing the user when you pick them up. For instance, in the gaming world, you have like Call of Duty, and you have the button layout for Call of Duty. Well, if you're going to create a first-person shooter, you're not going to deviate too much from that button layout, or you're just going to confuse users. You want them to pick up on that as quickly as they can, right? Um, so that's one of the first things that you want to do when you have an experience. And then the second thing is you want to identify who the target audience is. So for instance, if we wanted to develop our experience for high schoolers, we're going to have a different experience for high schoolers than if we developed it, say, for fourth graders or for 50-year-old people. So there's a lot of changes and challenges that you might face with developing it for different groups, and certainly design decisions that you would make in developing it for different groups. After that, then you would create a design document. This is arguably probably the most important part of the development process, because here, as much as we all don't like documentation and writing things, you have to you have to communicate clearly what you want to do. And when you're working with a team, you have to make sure that all the team members understand from that design document what is going to be done. And that design document lays out literally kind of everything about the experience, like from is it going to be a serious experience? Is it going to be cartoony like? What's the art direction? What's the mood? Who the users are, which we identified. Also, like what technical challenges you may have, and a lot of other things. You go, and it leads then into developing a script. and depending on how complicated your game or your experience is, the script can actually be huge. The script is almost like a movie or a play script where you have to define and talk about each one of the scenes and what happens in the scenes. You have to write down the dialogue of what non-player characters or NPCs may be using, and then beyond that, you have to then continue on and actually branch off different decisions that users may make, and then what may happen because of those decisions in the game. So the scripts can actually be pretty complicated for game design. From there, we move to storyboarding. And I don't know if you've ever seen storyboards like in movies or whatever, but they're essentially where an artist sits down. You don't have to be much of an artist as long as you can get the point across, but you sit down and design story beats in the story or important scenes, and you design what the action is going to be or what they may look like. And then you take this storyboard and you essentially do some rough voiceovers based on what you wrote out in the script. What this does is create you an idea of how long is your experience going to last. So for instance, if you are designing an experience or a game that you want to last for 7 hours, and you go through your storyboard and it only lasts 1 hour, then you've clearly got a problem and you need to add some more things into it. So it gives you an opportunity to sort of step through the game at an early stage without even coding, without even doing anything like that yet, just to get an idea of, is this game going to meet our needs?
Okay, I've got questions. One,
Yeah.
how early on did y'all know that you wanted to do a virtual reality experience?
So they wanted to do a virtual reality experience pretty early on. The problems they were having when I came on board was the expense of actually bringing devices in. So when the Quest was introduced, that sort of solidified their thoughts of wanting to do a virtual reality experience. They wanted to have it as immersive as possible. They'd seen demonstrations and things with VR, and they understood just how immersive it can be when you're actually in that environment. And they also wanted to have a more gamified experience for the high schoolers, so they would be more interested in it than just standing up and giving PowerPoints.
Okay, and you mentioned some technical difficulties somewhere in there. Can you give me an example of what something like that may be?
Right. So with the Quest itself, the headset runs with a Snapdragon 835 processor, and essentially that's a processor that is in a lot of phones, especially Android devices, that is used, and it's powerful, but for a phone. But when you start putting a lot of graphics and different things on it, you can definitely run into issues with performance. And for us, it was always a battle of how do we make this as realistic looking as possible, but still maintaining performance. With the Quest as well, you have to keep a frame rate of 72 frames per second. That means every second there's 72 frames that get displayed to the eyes. If you drop below that, you can induce motion sickness in people, especially in VR, because you have drop frames and you have things that are going slower than what your vision expects them to be. And so it's a challenge to keep a realistic looking environment and keep things happening in there that are keeping it at 72 frames per second.
Okay, does the power capabilities of the Quest limit your time? Like, was that any consideration? It's about 7 to 8 minutes, if I recall. Was that pre-planned? We want it to be 7 to 8 minutes long, and then it just happened to work, or is the technical capabilities of the Quest limiting it to 7 to 8 minutes?
So in our case, it was two things. Number one was budget in development and how much we could that we could put together. But the other thing is we wanted to keep it so that we could get as many students possible through the experience, but not have it too short, right? So we felt that between 7 about 7 or 8 minutes was a good time because that gave a couple of minutes to get in and out of the headsets and to clean them between participants and things. So we wanted to keep it that way for both of those reasons,
Okay, I
really.
got one last question, and I'll let you take back over. You
No, sure.
have all these. You're talking about storyboards, which I am familiar with from having to do videos and that type of thing. Are you bringing in people that specialize in these, or are coders having to basically figure out art direction and be creative and develop storyboards?
So generally, it's people that kind of specialize in it. It's kind of rare to have people who code and can do art as well. And so generally, you want to have people who work on a team together. You have, especially in video games, um, you have 3D art and animation, which is that is 100% different from coding, but that is a huge part of the video games, right? And uh, even though those artists may or may not be the storyboard artists, depending on how big your team is and how much money you have to spend, um, you definitely want to have people who understand the space. There's a lot to keep up with in coding and in video game coding and programming, much less than art and optimization of art and keeping all your vertices down and how did you bring that in and make it look good. There's so much there that it's very hard for one person to keep up with that. Not saying it's impossible, but it's generally not done.
Right. Okay. How close would you say that this development process resembles some buzzwords like waterfall or agile?
So I, I would say it was actually a combination of both. On the front end, there's a lot of planning and there's a lot of figuring things out, especially uh, when you are in VR and it's so new and you don't quite necessarily know how people are going to react to it, especially non-gamers or people who haven't been in VR before. So there's a lot of iterative processing going on there and iterative design. And in that case, it's pretty close to Agile, right? But at the end of the day, um, once you get like a what's called a vertical slice set where it's a representation of what the game or the experience is really going to look and feel like, which might have finalized art assets and finalized voice acting and music and the mood and the lighting and all these other things. Um, when you have a small piece of the game that you've defined to show people, yes, this is kind of what it's going to be like, that's where you can sort of stop the iterative process and move a little bit more to a waterfall approach to actually get it done, if that
Yeah.
makes sense. So on the front end, I would argue it is probably a lot more agile, and on the back end, once you have things a little set, it goes a lot more waterfall.
Yeah. Was there ever like a conscious decision of we're going to be very agile in our development, or it just things just kind of came together that way?
It just really came together that way. A lot of times, especially in industry, if you ask like 5 different companies what their definition of agile is, you'll get 5 different answers, right? Because I mean, the very definition of it needs to be flexible and adaptable to the needs of the team. And so, um, in this case, it was somewhat agile because you know while we didn't have necessarily a specific customer other than our um, Alabama Power friends, uh, and they were definitely involved in it. We did though have a few iterations of what some of the interactions and things were going to be like, and that's hard to do in Waterfall. Um, and so after that, then we kind of sort of stepped things up once we had a lot of this solidified.
Awesome. You've hinted at the possibility of kind of migrating away from Unity. Can you kind of touch on why and maybe what you're considering?
Yeah, so Unity um, is a good game engine, but it itself is software that's under development a lot. And right now, Unity is going through a process to improve themselves, and that's kind of creating a mess for developers, especially in the VR space. Um, we are moving from Unity to Unreal, uh, and that's another game engine that is used by a lot of the AAA studios. Fortnite was developed in Unreal. Jedi Fallen Order is developed in Unreal. There's a lot of games that were done and developed in Unreal. And so we're moving to that not only because it has a much more mature graphics pipeline, but because it is a little bit more stable right now, and it does offer us a stronger path forward instead of having to try to figure out what's broken in this build or whatever.
Okay. In Unreal, I believe it's C++, like under the shell, right?
So Unreal actually has two ways to develop for it. One of them is C++, and you are correct. That is the way underneath everything. But another is called Blueprints. Blueprints are a very visual scripting language, and a lot of places can do like about 90% of a game in Blueprints. Um, and from what I understand too, for a lot of artists, they can come in and between Unity and Unreal, they definitely are able to pick up on Unreal much easier because of Blueprints than having to learn programming and things that are really kind of foreign concepts to them, but they're able to pick up on Blueprints since it is really kind of visual.
How difficult do you think it is to transition into like one of these environments? If I come in this only knowing Java and never really touched a game engine, like, do I just not stand a chance, or is the transition pretty hard?
Um, I would say the transition is not that difficult. It's really more of your mindset, right? And there's obviously a lot of tutorials and ways to kind of help you transition into there, out there on YouTube and with other services as well. Um, it's if the like having a C or a Java background would definitely make learning C sharp very easy. It would help definitely with C++. I'd say C++ is more difficult and more um, definitely there's a lot more what they call boilerplate that you have to do for C++, and it's a lot more wordy, if you will, than Java or than C sharp. Um, and then with the blueprints that I mentioned, you still have a lot of the same concepts, like you have, variables and functions and things like that. And they're still there. They're just done in a different way. So I think it even helps there. So I think having the programming background definitely helps um, coming into there and being able to manipulate and actually develop the games. Um, but and definitely, you know, any sort of C-based language, like Java, like C sharp or whatever is going to help
Yeah, you
out
said a
because you're really learning. I'm sorry too. The important thing too is the logical steps that you're learning. It's not so much the
good.
syntax, because the syntax you can
Yeah.
pick up on, right? And that's just sort of learning a little bit of rules. But you have Java, you have you know functions or methods, you have uh, objects, and you have switch statements, everything like that. You have all of this that is easily transferable to another language. Like in C sharp, it's I don't want to say the same thing because it's not, but it's pretty close to the same thing. So the syntax is just not that much difference, but it's the principles that you take over and that you can
Thank you.
apply.
Those are words I have said, and it's nice to hear them coming from someone else. So maybe the students will actually believe me. You said a term in there, boilerplate. Can you explain what that means to us?
Yeah, boilerplate is just like it's sort of the amount of code that you have to put into your programs in order to do kind of anything, really, I guess, in a nutshell. So, like if you wanted to, even when you're setting up, like I think you guys use a main in your Java programs, right? When you're running them, and it outputs things and it runs things through that
Right.
main. function, that's kind of considered boilerplate, because if you don't have that, then you kind of can't run the program, right? So it's sort of the initial setup text and things that you have to put in there.
Okay. You told me when developing this, you had to brush up on some pretty advanced math. I had made a statement in one of my classes that the need for math is a little overblown in computer science, and you stepped in and were like, whoa, hold on a second. I had to learn this thing. Can you tell me what you had to brush up on, and maybe briefly explain that, and what your thoughts on math is in software development?
So I think math, we'll do that part first, and I'll talk a little bit about what I had to do. I think math is important in software development because it actually helps you learn logic and how things are put together. And when you're talking about developing in 3D space, I think it's even more important, right? So keep in mind too that when I'm talking in the software development like this, I'm really talking more of 3D space in games. And it's not necessarily the same thing as if you're developing an app for, an iOS device, or even in the industry where you're developing, web apps or different things which may not even be released to the public, which I'd say that's most of what most software is, right? Um, some of that is probably, I would say, pretty basic math, basic algebra, things like that. But in 3D space, you have a lot of different math that you have to deal with. What I was talking about was vector math, where so in virtual reality, you set up your boundary in your room, which is your physical space, right? And then you're standing in that physical space. And one of the errors that or bugs that we had in our program was when we would teleport in virtual reality or move to another location, it would move us in virtual reality, but offset us by the amount that we may have moved in our physical space. And so in order to calculate how much that offset was, we had to use vector math to determine where we were in physical space and sort of line that up in the virtual space, if that
Yeah,
makes sense.
yeah, that's really cool. Nerding out over here over math. Uh,
Right. But you wouldn't have that like in, if you were developing accounting software, you're
right.
not going to have that, right? So it really depends on the area that you might want to go into.
Yeah, that's really interesting because I mean, my thought was that the hardest math that you kind of ever encountered with software development was kind of physics based, and most of these game engines kind of handled that. But
Right. A lot of them do. A lot of, and it depends on, the studio or whatever that you may go work for. A lot of studios actually create their own game engines. And in that case, you're going to be writing that physics yourself, because it's going to be very tailored to uh, whatever applications they're making. That way they can just get the absolute most performance out of whatever it is they're needing. Because I should mention too that like Unity and Unreal both, they do allow you to create a lot of different types of games, but that comes with, baggage or functions and things that you may not need for your game at all. And so if you have that and if you're developing that in-house as your own studio, then that's extra, a few processing cycles that you may not need. And sometimes every single, bit of processing power is what's needed to help make your vision a
okay,
reality.
this viewer question I feel like is pretty related. What is something you think we should know if we want to study computer science? Right, we've kind of talked about the math and that sort of thing. So the way I
Right.
kind of phrased this question to you off camera was that if someone goes through a computer science program, what are they not learning that industry needs them to know?
Right. And definitely the first thing is version control, without a doubt. That's not necessarily coding itself, but version control is very important, especially when you're working with teams and introducing, um, potential bugs or whatever into software. You want to have a way to roll that software back or go to a previous state that it was before that you introduce the bug. So that way, if you have to get something out into production, or if you have to release something quickly, that you have a version that you can go back to. The other thing it does is on version control is gives you the freedom to explore and to try new things without thinking, well, if I do this, I'm really going to mess up my program and it's just going to be a huge mess. So definitely version control. Another huge thing is literally communication skills. I mentioned, design document. I mentioned um, teams. As much as we all love group projects in school, when you get out, you are working on teams generally for these things, and some of these games can have hundreds and hundreds of people on them, depending on how big the experience is. So, you have teams of teams, right? And so you have to be able to communicate in those situations. So definitely communication skills are another thing that sometimes we kind of overlook as we're in our bubble, because you have to deal with people, even
Yeah.
virtually, like right now.
Can you tell us a little bit about your background and how you got to where you are?
Sure. Well, so when I was in college, I actually studied mechanical engineering with an emphasis in thermal and fluids design. I never used my mechanical engineering degree. While I was there, I got into programming, and when I graduated, that's what I got was a job as a programmer. I did that for several years, and when my kids were born, I was fortunate enough to take some time off and stay at home with them. I did do some consulting on the side just to sort of keep my technical chops, but for the most part, I stayed at home with them for a while. And then an opportunity came up at Georgia Tech Research Institute, where I went there and started developing apps for the Android and iPhone um, back then, and stayed there for about 10 years or so. Started getting into VR, um, and eventually moved on to Southern Company.
Okay, so it sounded like you found programming in college. A, what attracted you to that? And then right out of college, you said you had a programming gig. What was that like?
Right. So um, in college, I co-opted, which is kind of like being an intern with the Tennessee Valley Authority. And one of the things we were doing, and keep in mind this is like in 1990, so this is a long time ago, but we were actually creating a graphical decision support system of the Tennessee Valley Authority. And back then we were trying to pull in data from all these different areas that normally didn't share their data, and be able to have everyone share data and use it. So it was quite honestly a little bit above its time on what it did, and we represented everything and the entire TVA system, which they were a power company too, on a graphical interface where you could click on one of the um, power plants or hydroelectric plants or even nuclear plants and get real-time information about that, which again for its time
Yeah.
was quite a bit. Um, what I began enjoying with that, because I actually I'm a developer, but I do also like to draw and I like art. And what I began enjoying from that was actually creating and seeing things on the screen that I had developed, right? So in a way, it was like art, because you're starting with nothing and you're writing code, and you're getting these things on the screen that literally you created, or you and your team created. And to me, that was great. That was just a wonderful experience to be able to um, create that sort of thing, and know that, look, we did this, right? And so you get a lot of pride out of that, which I really liked. And while I was there, I was learning C, even though back in college the professors were teaching Fortran, um, which that's another language, and I was able to take like my C skills back and uh, kind of enjoy that. And so after college, I actually moved from Tennessee down to Atlanta for my first gig, where I was developing um, some applications with a database and got sort of recruited to go to Ohio and work. So I did that as a consultant, and then after about a year of being too cold in Ohio, came back to Atlanta, where I continued to be a consultant for a while. I did the startup thing where I was, uh, again, this was when we were still dialing up on the internet, but we were actually running and trying to create 3D worlds over the internet back then, where you could um, actually have e-commerce in 3D
Whoa.
back then, which is what our startup was. Then the bubble burst, um, and we, we were actually in front of investors when that happened. They were on their phones looking at how much stock they were losing, literally while we were having our meetings. So that was bad timing. Um, and so we put that up on the shelf, and I just went back a little bit to more web consulting and development, and um, then my kids were born, and I was able to take off and spend time with them. So uh, yeah, and then went to Georgia Tech. After that, I met them actually through. Um, I met the person I was working with Georgia Tech actually through Timber Ridge. He was another parent there, and we got to talking and realized that my skills could be useful to him. Um, and so I started developing apps there and did some other things for the Department of Defense while I was there, and moved on to Southern Company then eventually.
Wow, that's awesome. We got one question on the document that we have not quite hit. It's a viewer question, and I'm going to ask it. In the meantime, live viewers, if you got any questions, go ahead, get those in chat. We'll see them, hopefully respond. But did you consider adding any type of tactile responses based on like user input, like getting shocked in the VR experience, for instance?
Right. So actually, in our experience, we do have what's called haptic feedback. Uh, Haptic feedback is if you've play Xbox or PS4 or whatever, and when the controller vibrates, like when certain things happen, that's called haptic feedback. So we did add the haptic feedback. For instance, when the phone vibrates, it kind of vibrates like your phone would really, and we don't really have an area where you get shocked per se, other than the microwave simulation when you're pouring the water, and it does give you feedback during that motion as during that time as well. Um, they do have, interestingly enough, uh, like a vest, a haptic vest that you can put on, which actually can deliver uh, shocks or the feedback to different parts of your body. So if you have that in a game, and for instance you get hit in the back, you would feel it in your back, or get hit in your chest, you would feel it there, which is kind of cool. But yeah, so we did add the haptic feedback into there.
Okay, Mr. Wright. Darryl, as you've told me multiple times to refer to you
That's
as.
fine.
I guess we're going to wrap it up there. Any final thoughts?
No, thanks for having me. Certainly, any other questions or whatever, just forward if people think of things. But you know, as you go through things, I guess, and you're trying to figure out what to do, I would say just be flexible, right? Just like us moving from Unity to Unreal, or me moving from C, learning Fortran, whatever. Understand that it's don't get so hung up on I know Java, so that's what I'm going to use, right? Be flexible and understand that your principles and the things that you learn are going to carry over, and because the people who are flexible could continue their career. Otherwise, you get locked into one thing, and you could be left behind when the world moves on, right? So um, just learn what you can and understand that it's all principles, and it's kind of the same thing no matter what you're doing it in.
All right. Thank you so much for being with us today. That's going to wrap us up.
Awesome. All right, thanks a lot.